Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to learn one more technique to find integration of rational functions, that is, integration using partial fractions. Let us first define rational function. If fx and gx are polynomial functions such that gx is not equal to 0, then fx by gx is called a rational function. Also, if degree of fx is less than degree of gx, then fx by gx is called a proper rational function. And if degree of fx is greater than degree of gx, then fx by gx is called an improper rational function. Now, if fx by gx is an improper rational function, then by dividing fx by gx, we can express fx by gx as the sum of polynomial and a proper rational function. Any proper rational function px by qx can be expressed as the sum of rational functions, each having a simplest factor of qx. Each such fraction is known as partial fraction. Now let us take an example to make this more clear. Here we have a rational function 2x minus 3 divided by x square minus 3x plus 2. In this rational function, degree of numerator is less than degree of denominator. So this is a proper rational function, and we can decompose this into partial fractions. For that, we will first factorize this denominator. Now we can write 2x minus 3 divided by x square. Now here we split this middle term minus 3x as minus 2x minus x, then we have plus 2. That is further equal to, it's 2x minus 3 divided by x into x minus 2 minus 1 into x minus 2, or that is equal to 2x minus 3 divided by x minus 2 into x minus 1, or we can write it as 1 by x minus 2 plus 1 by x minus 1. Now on cross multiplying this, we get x minus 1 plus x minus 2 divided by x minus 2 into x minus 1. That is equal to 2x minus 3 divided by x minus 2 into x minus 1. Now we have decomposed this rational function into two rational functions, and these are called partial fractions. Now let us decompose one more proper rational function into partial fractions by using a proper method. If we have a proper rational function of this type, while in denominator we have two different linear factors, then we can decompose this rational function into partial fractions by putting this equal to a divided by first linear factor, that is x minus 3, plus b divided by second linear factor, that is x plus 1, while a and b are constants yet to be determined. Now to find a and b, we can write it as a into x plus 1 plus b into x minus 3 divided by x minus 3 into x plus 1, or we can write it as 2x plus 3 is equal to a times x plus 1 plus b times x minus 3, or this is further equal to a into x plus a plus b into x minus 3 times b. That is further equal to a plus b, a plus b, take x common, then we have a minus 3b. Now, equating the coefficients of x on both sides, we have a plus b is equal to 2. That is a plus b is equal to 2. Name this as equation first. Also, equating constant terms on both sides, we have a minus 3b is equal to 3. A minus 3b is equal to 3. Name this as equation second. Now, subtracting equation second from equation first, we get a minus a cancels, b minus minus 3b, that is 4b, is equal to 2 minus 3 is minus 1. That implies b is equal to minus 1 divided by 4. Now, substitute the value of b in equation first. We get a plus, instead of b we have minus 1 by 4 is equal to 2, or a is equal to 2 plus 1 by 4, or we can write a is equal to, it is 4 2s are 8, 8 plus 1 is 9, it is 9 by 4. Thus we get value of a as 9 by 4 and value of b as minus 1 by 4. Now we substitute these values in this equation and we get, since a is 9 by 4, so we write 9 by 4 divided by x minus 3 plus b is minus 1 by 4 divided by x plus 1, or we can write it as 9 by 4 1 by x minus 3 plus, minus 1 by 4 into 1 by x plus 1. Thus we have decomposed this proper rational function into partial fractions. Since we have decomposed this rational function into partial fractions, therefore, to find integration of this rational function, we have to integrate its partial fractions. So we can write integral 2x plus 3 divided by x minus 3 into x plus 1 dx is equal to integral 9 by 4 into 1 by x minus 3 minus 1 by 4 into 1 by x plus 1 dx. That is equal to, its integral 9 by 4 1 by x minus 3 dx minus integral 1 by 4 into 1 by x plus 1 dx, or that is further equal to 9 by 4 is constant, so we can write 9 by 4 integral 1 by x minus 3 dx minus 1 by 4 is constant, so we write 1 by 4 integral 1 by x plus 1 dx. Now here in denominator we have x minus 3, and differentiation of x minus 3 is 1, that is in numerator, so this is equal to, it is 9 by 4 log of denominator, log of mod of denominator, x minus 3 minus 1 by 4. Also in this case we have x plus 1, and differentiation of x plus 1 is 1, that is in numerator, so this is log of mod of denominator, log of mod of x plus 1 plus constant of integration c. That completes the integration of this rational function. Now in my next lecture I will continue this topic. Till then, take care of yourself. Thank you.